Welcome to Intelligence Gateway.
JavaScript Course Lecture 6. In this lecture, we will learn about asynchronous programming, introduction to asynchronous programming, callback functions, promises, and asynchronous functions, handling asynchronous errors, fetching data from a PIS conclusion, introduction to asynchronous programming. Welcome to the world of asynchronous programming. Asynchronous programming is a way of writing code that allows multiple tasks to be executed simultaneously. Without blocking other processes, this means that your programs can run faster and more efficiently than ever before. But why is asynchronous programming so important? Well, in today's fast-paced world, users expect applications to be lightning fast and responsive. Asynchronous programming allows you to deliver on these expectations by making your applications faster and more efficient. By using asynchronous programming techniques, you can create applications that are more responsive, scalable, and reliable. Callback functions in asynchronous programming. A callback function is a function that is passed as an argument to another function and is executed when that function has completed its task. Callback functions are commonly used in event-driven programming, where an action triggers an event, and a callback function is executed in response. For example, imagine you are building a web page that needs to fetch data from a server. You would use a callback function to handle the response from the server once the data has been retrieved. The callback function would be executed once the data has been received, allowing you to update the web page with the new information. Promises and asynchronous functions. Promises and asynchronous functions are powerful tools for simplifying asynchronous programming. They allow you to write code that is much easier to read and understand, and they can help you avoid some of the common pitfalls of asynchronous programming. A promise is an object that represents a value that may not be available yet, but will be at some point in the future. You can attach callbacks to a promise that will be executed when the value becomes available. This makes it easy to write code that waits for asynchronous operations to complete before continuing. Asynchronous functions are functions that return promises. When you call an asynchronous function, it returns immediately, without waiting for the operation to complete. Instead, it returns a promise that you can use to get the result of the operation when it is available. Promises and asynchronous functions. One real-world example of using promises and asynchronous functions is fetching data from an API. You can use an asynchronous function to make the request and return a promise that resolves with the data when it is available. Then, you can attach a callback to the promise to process the data and update your application state. Overall, promises and asynchronous functions are powerful tools for simplifying asynchronous programming. By using them, you can write code that is more readable, maintainable, and scalable. Handling asynchronous errors. Asynchronous programming can be tricky, and errors are a common occurrence. One of the most common errors is the callback hell, where nested callbacks make the code difficult to read and maintain. A solution to this is to use promises, which allow you to chain asynchronous operations without nesting callbacks. Another common error is the race condition, where two or more asynchronous operations try to modify the same data at the same time. To handle this, you can use locks or semaphores to ensure that only one operation can access the data at a time. Fetching data from Apis. When working with Apis, it's important to understand the basics of asynchronous programming. Asynchronous programming allows us to make requests to an API without blocking the main thread of our application. This means that we can continue to perform other tasks while we wait for a response from the API. To fetch data from an API using asynchronous programming, we typically use the Fetch API or an HTTP library like Axios. These tools allow us to send HTTP requests to an API and receive responses in a way that is easy to work with. We can then use this data to update our application in real time, providing a seamless user experience. Conclusion. In conclusion, we have learned that asynchronous programming is a powerful tool for improving the performance of our applications by allowing multiple tasks to be executed simultaneously. We can make our programs more responsive and efficient. We have explored several techniques for implementing asynchronous programming, including callback functions, promises, and asynchronous functions. We have also discussed how to handle errors that may arise in asynchronous code and how to fetch data from apps using asynchronous techniques. Overall, it is clear that asynchronous programming is an essential skill for any modern developer. By mastering these techniques, we can build faster, more reliable, and more responsive applications that meet the needs of our users.
Thanks for watching. For more information, like, comment, and subscribe our channel.